Hi there. I'm glad you're checking this video out. I really like the method we use in this video, but we'll perhaps see some problems where it does not work. So this method, I think, is a lot cleaner, but it only works in certain situations. So it's a shortcut you have to be careful about taking. But it'll help us figure out some answers and usually pretty a lot more quickly than we do originally. And if you are a math nerd or you just want to know how everything connects together, the reason why this works kind of connects back to factoring in Algebra 1 and then some of the rules that you might see in Algebra 2, but it really has to do a lot with factoring from Algebra 1. Okay, so with this second method, we're again going to start by reading through the problem because that's important. We want to know what we're trying to find. So we've got a rectangular prism, and it says if the length is doubled, then which of the following statements about its volume will be true? So with this, I'm glad they gave us a volume because this method works for volume. If it was surface area, this method would not work because it's only one length. But here, if it's a volume, this method should work for all volume problems. I can't think of any situation off the top of my head where it does not work because volume is all multiplication. When you start throwing in some of the addition that you see in surface area, that throws off some of the factoring stuff. But for the second method, what we're going to do is again start with the formulas, and I'm actually even going to set it up like the first method. So we're going to take the volume of the new shape divided by the volume of the old shape. But this time I'm not going to pay attention to the numbers they gave me at all. My goal here is to get problems done quickly and to use mental math. I like to kind of challenge myself with that whenever possible. It's also nice to have shortcuts and smaller numbers. So here, the volume of rectangular prism, that normal formula is length times width times height. And then for our new shape, what we're going to do is apply the rule they gave us. So they said the length is doubled. Doubled means we're going to multiply that length times 2. So we've got 2 times the length, but the width and the height, those are the same as they were before. And then now what we're going to do is we're going to go through and cross out everything we can. So as long as everything is being multiplied, you can apply this rule. So it's all multiplication. You've got height and height, those cancel out. Width and width, those cancel out. And length cancel out. And what are we left with? We're left with this 2. And so I'm going to bring that down. We're left with 2. Or if you write it as a fraction, 2 over 1. Then scrolling down to check out our answers, we're going to see it's either 2 times as big, or in this case, IXL is asking about the ratio, so it wants the ratio. Remember, the top number comes first, so we've got 2 to 1. This is our answer. Okay, so done a lot more quickly than the first problem we did. Didn't even have to plug in some numbers. Okay, next problem. It's nice. Here, this time our method will work because it's all of the sides. So it's important to note that this method works because all of the sides are being doubled. If they weren't, or if they were changing by different amounts, it wouldn't work. So if it helps to see it written out, or if you take notes, that's kind of important to notice. So with this, again, we're going to set it up with the surface area of the new over the surface area of the old. And here, kind of bear with me because this gets kind of tedious. So for the old shape, we've got 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Then for our new shape, we've got 2 times, but this time our length, width, and height, those are all doubled. So we've got 2 times this, 2 times the width, 2 times the height. So we've got 2 times 2L times 2W plus 2 times, and here we doubled that length and we doubled the height, plus 2 times the width and 2 times the height because we doubled each of those. Then if you look at it from an algebra standpoint, we're going through and kind of factoring it out to look something like that. So on the top, we can find this entire expression in there. But the way I'm going to look at it is I'm going to compare what is different between the two, leave that out, and cross out what's the same. So here, looking top to bottom, what is the same? We've got the 2's that are the same. We've got length that's the same and width that's the same in the first part. And what's left is 2 times 2. So we're left with a 2 times 2 here. And what we want to do for this method to work, for it to truly be factoring, like you saw in Algebra 1, is we have to be able to get a 2 times 2 or a 4 from the other expressions as well. So let's check and see if that happens. So here we've got 2 and 2, we've got a length and a length, and we've got a height and a height. What's left? We've got a 2 and a 2. So 2 times 2, we've got a 4 again. So far, so good. But we've got to check all 3 of them to make sure we can factor out everything. So in the last expression, we've got 2 and 2 we can cancel out, a W and a W we can cancel out, an H and an H that we can cancel out. And again, we're left with a 2 and a 2. And so with this, if you're sticking to your technical algebra rules, if you were to go through and write this as a factored expression, you would write out 4 times all the rest of that. So it'd be like 4 times 2LW plus 2LH plus 2WH over the denominator. But here for this problem, you don't have to go that far. You just know those cancel out. And as long as you get this same number for all 3 of them, that's going to be our answer. So it's going to be 4 to 1. Okay. Hopefully that made sense and you didn't get too bogged down in the factoring. Mainly you're looking for what can we cross out if it's the same. And if you're working with surface area, remember the same number has to be applied to all 3, the length, the width, and the height for that to work. So here with this problem, if it's a cylinder, honestly, I would go back and I would use the old method or method 1 to do that, where you just plain plug in the numbers and divide. I'm going to pause the video, see if it works out, but I'm not sure it works out with cylinders. And I set it up, and it will work for this problem because both the radius and the height are being tripled. So both what we call linear measurements are having the same thing done to them. And so that'll make sure this ends up working. And to kind of look at that, what I'm going to do is I'm going to simplify the top expression. And so I'm going to go through and here I'll use different colors to emphasize what's the same. We've got 2 pi, but then when you do 3r squared, remember you're squaring both of these, not drawing an arc well. So 3 squared is 9, and r squared is just plain r squared. And then if you keep going, we've got 2 pi, that's normal from the bottom, so plus 2 pi. But then we've got a 3r times a 3h. And the 3's are different. The r and the h are there like normal, but the 3 and the 3 are not. So I'm going to go ahead and multiply them. So times 9, and then the r and the h are normal. And now looking at this, the bottom, the denominator stays the same. I'm going to look at what's different. And so here, the 9 in both of these expressions is something different from the original. Otherwise, you've got 2 pi in all of these. You've got r squared here. You've got rh here. And so if you think about it in terms of algebra, you could take the 9 out of both of these expressions and rewrite it as 9 times 2 pi r squared plus 2 pi r h. And if you were bored, you could take the 2 out as well, but that's part of the original formula, so I'm going to leave that. But this number that you can factor out, or the number that, if you like to think about it this way, the number that's different, that's just a 9, that is going to be what creates your ratio. So your ratio is going to be 9 or 9 over 1 or 9 to 1. So here, 9 to 1 is our answer. Let's take one last example of this, and here I won't go through and talk a whole lot about factoring. I will just focus on going through and what crosses out. If I have time to do this pretty quickly, I just pause the video to check. So here, going through, taking a look at this, we want to compare the volume of the new to the volume of the old. Volume is wonderful because it's all multiplication and we can cross things out super easily. But here, the volume of a sphere, I'm going to check my reference sheet just to make sure I have it. Yeah. So it's 4/3. I'm going to actually write it for the old original one. 4/3 pi r cubed. That should be a 3. And then for the new volume, the radius is doubled, which means it's multiplied by 2. So we've got 4/3 times pi. And then I'm going to put this in parentheses because we've got 2r, 2 times the radius cubed. Then if you go through and simplify, you can distribute the cubed to both of those. Remember, cubed means you multiply it times itself 3 times. And then what's left, we've got 4/3 pi. That stays the same as we had originally. Denominator stays the same as we had originally. It's just up here on top that we've got 2 cubed. 2 times 2 times 2 is 8. And then r cubed ends up being the same as we had in the denominator. And then we can go through, cross out what's the same. So 4/3 are the same. The pi's are the same. R cubed is the same. The things that are left over, if there was more than one, we'd go ahead and multiply it. Here it's just 8. So our answer is going to be 8 or 8 to 1. Hopefully that helps out. Maybe you like that handy little formula. Or shortcut. Remember, it only works if you have volume. So always works if you have volume. With surface area, it only works if you're changing all of what we call the linear measures. So here it would work because it's both the radius and the height that were changed. If it was only the radius, this method doesn't work. You have to go back